Hey Algebra. Today we're going to do a ready check for chapter 11, page 673. And I'm assuming most of this should all be a review for you because that's really what ready checks are. They're checking to make sure you're ready to move on to the next chapter with some skills that you've learned in the past. So, we probably could have skipped this section. I think you guys understand how to do these types of problems pretty well, but you had a long test yesterday, and I don't think it's bad to give you a lighter assignment today. So real quickly, just a reminder of how to do each of these types of problems, and I'll do a couple of the problems with you from our actual assignment later on in this video too, and I'll keep the video as quick as I can. But when you're solving proportions, if you can just look across the proportion and figure out what's going on, then you can just do it that way. That's fine. Otherwise, they're going to have you solve them using the algebraic method, which I'll remind you of. So notice on this one, for instance, if I'm dividing by 3 to go from this side to that side, right? So I can do the same thing up here. So x equals 5, right? Now this one I can't look across and figure out. This next one, I can't. There's nothing I can multiply 5 times to get 8, at least not an even number, right? So this one we'll solve using the algebraic method, right? We'll look at cross pairs. Remember, cross pairs in a proportion, equal each other, okay? So 7 times 8 is 56 equals 5 times x, right? Now I can solve it using just solving an equation, right, method. So 56 divided by 5. 1 times 5 is 5. Add an extra decimal and 0, and there we go. So we end up with 11.2, right? And so x equals 11.2. So that's solving them using the algebraic method. You can certainly use the look across method for the easy ones, and for the couple of them that you might need to use an equation to solve, don't forget to solve it that way. It's algebra after all, right? So they're having you do equations using algebra skills. Notice number 5 is also a proportion problem. It says Joe is making a scale drawing where 1 inch equals 5 feet. So you'll set up a proportion then. They say how many inches will a line need to be on this drawing to represent 8 feet, right? So we'll put feet on the bottom here then, right? And you'll figure out how many inches that is. Again, use your cross pairs, right? 1 times 8 gives you 8 equals 5x, right? And then you could solve for x and you'd have that amount of inches for how long that line should be. So you'll do number 5 in a very similar way. Again, use an equation. I should see your work doing it that way as they're trying to get you to work on some of these algebraic skills. All right, then number 6 through 13, they're going to have you factor. Okay, it's been, a couple chapters since we first learned these factoring skills now, right? Remember, you've got really 3 main methods besides graphing and stuff that we can use to factor polynomials, right? Simply divide out stuff sometimes, and that's all you have to do. You might notice in both pieces that there's something you can divide out, and then you can't go any lower than that. Then we've got what I call the simple method. That's where you have something like this, right? Where you just have to think of, okay, what 2 numbers multiply together to give us that add up to this. Yeah, obviously that one doesn't really work. I was just making that up. And then remember, if you have a whole number in front of this first x, like, I don't know, something like that, right? Then you have to think of what 2 numbers multiply together, these 2 n numbers multiply together to get that would add up to this, right? And so then you'd put those in the middle with mx and px, right, when you solve, and then you'd have to factor them out by dividing into pairs and things like that. So we'll do at least one of each of those types just so you can see all of those again, because I know it's been a little while. This might be the one area maybe you feel a little bit of rust on these type of problems since it's been a while since we've done them. So let's do at least one right out of your assignment of each. Here we go. Notice this first one, number 7, which is actually number 7 in your work. You can do this right along with me. Is an easy one where we just have to divide something out. Notice all of these pieces have a 2 and an x in them, right? So we can just divide out a 2x. And notice that all that's left then is x minus 2, right? And so there's our final answer. That's all the farther we have to go. So a few of them are as easy as that. It's just dividing something out, and then you can't go any further or factor any further. Number 10 is what I call the simple method one, right? Where we look at this n number. There's no whole number out in front, right? So we can just look at this n number and say, okay, what are 2 numbers that multiply together to equal that? And you're probably thinking in your head d minus 3 and d minus 9, right? So those would multiply together to equal positive 27. And then you're done. You don't have to, solve for 0 or anything. That's it. You factored it, and there's your 2 pieces, okay? So that's one of the simple ones. Here is one that's got a whole number out in front, so we got to use the mx plus px method to solve. So we're going to think, okay, what are these 2 numbers on the end multiply together to equal? -3. So can we think of any 2 numbers that would multiply together to give us -3 that would add up to 2? positive 3 and negative 1, right? So we're going to set this up as an mx plus px problem. Remember these? And then we're going to put the positive 2 or positive 3 and negative 1 in for the m and the p. Remember how we did this? It's been a little while. 3x squared plus 3x minus 1x minus 1. So notice I put these two in right here and right here, right? Remember these? And then we're going to look for nice compatible pairs that we can group together. Obviously, these first two and these last two look like they're going to pair together really well, right? And then we factor, right, this first pair. Here's our pieces, right? And so what do they have? That's the same. They have a 3 and an x that is the same, so 3x. And then we're left with x, right? And then plus 1 because there's nothing left on this bottom one. And then notice these two pieces right here would be negative 1 times x, right? And then negative 1. So what do they have? That's the same. They have this, right? Negative 1, and then they have x plus 1. And so notice we can combine them at the end, right? We have 3x minus 1, those two outside pieces, this and this, right? And then they both have this in common. So there's our factoring of number 12. Number 13 will be very much like that one too, so just watch out. That's another mx plus px method of solving. All right, now number 14, they're saying the area of the rectangle is this. Okay, so what could possibly be the two sides of that rectangle? So in other words, you're just factoring it. You're going to factor it and get two pieces, which would be then the two sides. Notice there's no whole number here, so it's just the simple method to solve and factor this one. And then you'll have your two pieces, whatever they are. You know, like x plus 1 and x plus 5, or whatever they are. And that's your answer. The two factored pieces could be the sides, then, of your rectangle that you would multiply together to get that area in the middle, right? So that's just a quick review of how to do all those types of problems. Again, I don't think it'll be any trouble for you guys today, but I think you've earned a lighter assignment today after a long test yesterday, and just making sure that these skills haven't gotten any rust, because we'll be doing a lot of factoring and working with proportions in the next chapter too. So have a good day, guys, and enjoy the long weekend, and we'll continue on then with chapter 11 next week.